What is diffusion? The books, they have this irritating way of talking like professors and using complicated terms and everything, but I'm not a professor, you're not a professor, so we're just gonna help each other out. So what exactly do they write in books? The book definition is usually diffusion is the flow of particles at random from a region of higher concentration to a region of lower concentration down a concentration gradient. So what is the definition? What does the definition mean when it says higher concentration and lower concentration? I'm going to explain you these two terms, higher concentration, lower concentration. If you look here, higher, I have put a label above each of these beakers, high concentration and low concentration. So this is the beaker with, let's say, water, and these blue dots are ink molecules. And now if, like, again I define these two terms, I'm gonna end up with something like high concentration means more molecules per unit volume. But what does that mean again? Like, now imagine the circles between my finger is 1 unit of volume. So I put it over each beaker. You can see in one circle there are more dots fitting than in this one. So we can see that in per unit volume we have higher concentration here, and per unit volume we have lower concentration here. So this is what the concentration means, okay? This is high concentration, low concentration. So now we have that cleared out. We go over to the definition again. Diffusion is a flow of particles at random from a region of higher concentration to a region of lower concentration down a concentration gradient. Now, what does a concentration gradient mean? So I'm going to explain you the meaning of this term later on. But for now, I want to give you a general picture of what this definition is trying to say. So there are two analogies by which this definition can be properly defined, but I'm going to show you analogy number 1. Okay, so now suppose that this is a closed room, and you can see there is no outlet for the molecules to go out. So the molecules are just crowded up in this room, and they can't really go out anywhere. So I'm trying to explain you diffusion, right? So I'm just gonna keep this definition right here. Okay, so it's the flow of particles. So these are particles at random. You know, these particles are moving at random. Just suppose it's some gas, perfume or something, from a region of higher concentration to a region of lower concentration. Like, if you focus here, this is in higher concentration, right? This from a region of higher concentration to a region of lower concentration. This the reason why this happened, I'm going to tell that later. But for now, I just want you to focus that over here we have a higher concentration. Now suppose that I add a room, okay, and there is an opening to the other room, and the particles are allowed to go to the other room. Okay, now these particles are clustered together. They don't really like being together, closed up in a closed space. They want to obviously spread out. So when they see a vacant room, they would want to spread out. So they would move to the vacant room, and they would not be so concentrated, and they would spread out into something like this. So you can see they're nicely and evenly spread out all through the system, and they have the same concentration on both sides, which is low concentration right now, because they were obviously in a higher concentration before. and now they are in a lower concentration. So I just want this to stick to you, so just stay with me. Now remember this analogy. I'm going to come back to it, but I'm going to move on to analogy number 2. So now there must be a question in your head that why do the molecules move this way? They can stay in the place. I know I told you they don't like to be crowded, but like, they're not really beings. They won't do what they want. They're governed by laws. So I'm going to explain you as to how this happens. Okay, so this is my second analogy that I'm using. Okay, and so I just made this up to explain, okay, to younger students who don't really know about the gradient and stuff. So now imagine this is boy A, this is boy B. This is kind of different side. The ones at the park don't really have this ladder and they just go straight to the ground. But this one has a ladder, okay? And on either sides. Okay, so now boy A and boy B, they have chosen which ladders they want to climb. Boy A wants to climb the longer one, and boy B wants to climb this shorter one. Okay? So boy A climbs to the top, and he's pretty happy because he can slide down. But boy B is sad. He can't really slide down, I mean, he's already at the bottom of the slide. And he is on the top of the slide, so he can slide down. Now, so this side is this box. This side is this box. If you remember, this side was originally... Okay, this just got a bit messed up. Okay. This side was originally more concentrated, and it was on its own. So that would be like you remove this. If you remove this room, you remove this whole thing. He is just stuck on the top. Okay? And he can't really slide anywhere. He's on the top. Imagine these rungs are the number of molecules. So there are a lot of rungs and he is just stuck on the top. Okay? But once I join this, but when you attach this room, it is like you attach this part again. So he has somewhere to slide now, right? These molecules got somewhere to slide, and so they evenly spread out. They evenly spread out through the whole system. So imagine this the molecule, and when the molecules are in static position, like they are rungs. But when they start moving, imagine them as this boy. So now, just give me a second. Okay. So imagine this boy is one of these rungs. So one of these rungs turned into a boy. Okay. And so, of course, the side can't stay in the air. It comes down on the rung that's left. This rung turned into the boy. Okay. So sorry, this is getting messed up again and again. Okay, so then he slides down. Okay. He doesn't move anywhere. He just stays where he is. Okay, so when he gets on the ground, he most probably become happy again. Okay, so so boy A came down and he turns into a rung again, and he gets added here. So now let's count the rungs. 1 2 3 4 5. 1 2 3 4 5. The rungs became equal on either sides, just like these molecules became equal on either sides. Molecules became equal on either side. These rungs the number of rungs became equal on either side, and so now boy A and boy B both climb up, but they're on this flat plane. They won't really go anywhere. So what the point I'm trying to make here is that if you have a gradient, only then will the molecules be able to go somewhere. If you don't have a gradient, either there is nowhere else to go, or there is just plain, the number of molecules is just same on both sides and the side is plain. So that is what I'm trying to tell. This is what a gradient is. So the molecules here were in a greater concentration. I'm gonna put the definition in front of you. So diffusion is a flow of particles. Okay, if the particles are flowing, we're gonna say they're diffusing at random from a region of higher concentration. This was at higher concentration to a region of lower concentration. So now down a concentration gradient. So a gradient is also important. So I give it a gradient by adding an empty room, and then the molecules, they spread out evenly throughout the system. So from a region of higher concentration to a region of lower concentration down a concentration gradient, there was a gradient, I gave it a gradient, and it stops diffusing once the gradient becomes 0. When the slide is no more steep, it becomes straight again, we say the gradient is 0. Gradient is basically the steepness. Okay, so when the gradient is 0, the molecules are not gonna move. So molecules are kind of like us, okay? So they don't, you've heard the saying, what's the chemistry between them? What's the chemistry between those two people? So that's derived out of the fact that molecules behave like us. In many ways, they behave like us. And so they don't like being crowded, okay? And I mean, imagine if you were in a crowded room. Gets really stuffy in there, and then if you give an empty room, they like to move there, spread out evenly. And it's not like they're all gonna move to the empty room. They're not all gonna shift to that room, leave the previous one empty. No, that's not gonna happen. They're gonna keep moving until both the concentration in both the rooms is equal. Like, you're not gonna just then end up, all of you guys are not gonna end up being crammed up in the new room. You guys are gonna spread yourself. Some people are gonna prefer the older room, some people are gonna prefer the new room, and you guys are gonna spread over evenly. So now I hope that you can actually understand what this definition means. Don't learn it. I hope these analogies stick to your mind and you get what the point I was trying to make. So I hope you found this video useful. If you did, like it and subscribe to my mom's channel, okay? Because that motivates her and me to make more videos for you guys. Stay safe and healthy. Bye.